2016 AP exam, questions 5 and 6, BC Calculus. This kind of problem used to be the one I would hate the most, and now I love it because I know how to do it and there's nothing to fear, which is nice because there's usually always something to fear. So anyway, part A says find the average value of the radius of the funnel, and I remember that average value just means 1 over the limits, and it's from 0 to 10, of the integral from 0 to 10 of the function 1 over 20 3 plus h squared dh. Bring the 120 and the 110 out front, you get 1 over 200. Integral of 3 is 3h. Integral of h squared is h to the third over 3 from 0 to 10. Blast it all out. You have a little bit of funky math to do here. This is technically a non-calculator problem, but if you're doing it at home and you want to use a calculator, they will probably ask for an exact answer, and you should get 109 over 60, and please don't forget the inches. Very easy to forget that. Part B, people look at and say, how the heck am I supposed to know? And I say, hey, just put that on a curve, on a coordinate plane, and say, oh, those are circles. So I just need pi something squared, and it's r. So to find the volume, we go with pi out front, 0 to 10, 1 over 20, 3 plus h squared dh. So now again you have a little bit of math to do. You've got pi over 20 squared, 400 out front. Blast this out with multiplying 3 plus h squared times 3 plus h squared, 9 plus 6h squared plus h to the fourth, and then we have a little bit of calculus finally. Pi over 400, 9h plus 2h to the third plus h to the fifth over 5 from 0 to 10. Do a little math and you should end up with 2,209 pi over 40. Use the calculator math FRQ button at this point. If not, just plug in 10, find a common denominator. Actually, I don't need a common denominator. Divide out the 5 and add them up. It's not too bad. Alright, part C. This is the classic, and I don't know why, but I enjoy these problems. They say the funnel contains liquid, it's draining from the bottom. At the instant when the height of the thing is 3, keep that in mind. Radius of the circle is decreasing, keep that in mind. A rate of 1/5 inches per second. At this instant, what is the rate of change? Okay, well, I've got an r equals 1 over 20, 3 plus h squared, which I'm going to distribute out because otherwise I confuse students. And I just say I want to take dr dt, which is 0 for the 3 over 20, and then it's 2h over 20 times dh dt, chain rule when you do with respect to t. Well, we want to find out change of height, so we want to find dh dt. dr dt is negative, decreasing 1/5. You don't have to use the negative. You can do this lots of different ways. Equals 1 over 10. No, there's an h there, times 3 times dh dt multiplied by 10 over 3, and you get dh dt negative 2/3 inches per second. Very doable problem. If you have to go back and look at related rates and things like that, go ahead, but that's not bad at all. That's a I don't want to say freebie, but that's a question I think that most students really can do well on. Now our Taylor series, which is of course just a colossal pain in the butt. No other way to describe it. Not the hardest problem in the world, but it's very detail oriented. The good news is you won't see part D on the 2020 exam, but might as well practice it and get it down. So they kind of give you all this nonsense, and to find Where's for first terms for f? F, we go with, and we're about f of 1. F of 1 plus f prime of 1, x minus 1, plus f double prime of 1, x minus 1 squared all over 2 factorial, plus f triple prime of 1, x minus 1 to the third over 3 factorial. So they give us f of 1. F equals 1 plus f prime is negative 1/2, x minus 1 plus second derivative. Now we got to go to this weird little formula, plug in 2, negative 1 squared by 2 minus 1 factorial is just 1 over 2 to the second. So we're looking at x minus 1 squared over 2 factorial times 2 to the second. So 8. Took me a little while there. And then the final one, same idea, blast it out. It's negative x minus 1 to the third. The bottom is 2 to the third, 8 times 3 factorial. But then there's a 2 on top that you have to cancel out from the n factorial. And there it is. That's your part A. Pretty important to get that part right. And actually I have it wrong. Incomplete, I should say. Plus dot 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 plus negative 1 to the n. Let's see if that's right. The general term doesn't really count for these first ones. And then off we go. X minus 1 to the n. Alright, the n minus 1 factorial on the top cancels with most of the factorial on the bottom. And we're left with n, and the 2 to the n is still there. So that's our general term. That's tricky. Make sure you understand that. And you're probably like, yeah, I don't, but hey, you're on your own. Good luck. All right, part B. So now that you've got the first part right, the rest kind of run with that. Taylor series has a radius of convergence of 2. Find the interval of convergence. And this is where life gets nasty. N approaches infinity. Absolute value. Now we plug in negative 1 to the n plus 1, x minus 1 to the n plus 1, n plus 1 to the n plus 1 times n 2 to the n, negative 1 to the n, and x minus 1 to the n. Now the absolute value kills this, and I would write that out, but for lack of space I don't have it. I would also write this out, the limit of n going to infinity of n over n plus 1 is 1, so they're gone. And then it's the little trick I like to do. The whole 2n goes and the n goes. The whole x minus 1n and the n goes. So we're left with, that's really not equals, I'll just do an arrow. Limit as n goes to infinity of x minus 1 over 2. X minus 1 over 2 has to be less than, absolute value has to be less than 1, which means that absolute value of x minus 1 is less than 2, which means that negative 2 is less than x minus 1 is less than 2, which means negative 1 is less than x is less than 3, at which point I stopped like a moron. So this is brutal. If you get it, great. If not, you're losing a point here. It's not the end of the world. Let's plug in the 3 first. Alright. What are you talking about? Well, we got to check these endpoints. Always with the endpoints. So, plug in 3. 3 minus 1, 2, 2 to the n over 2 to the n, cancel. We have n on the bottom. So we have an alternating negative 1 to the n over n. And you would have to write all that out. Let's plug in x equals 3. I would get negative 1 to the n over n, 2 to the n, 2 to the n, x equals 3 works. X equals negative 1. I get negative 1 to the n times negative 1 to the n, 2 to the n. Where did that come from? Well, plug in negative 1 up here. You get negative 1 minus 1. Negative 2 to the n. Break that up. 2 to the n, negative 1 to the n. Negative 1 to the n times negative 1 to the n gives us 1 to the n. X equals negative 1 fails. So we come back here, we put that there, and then I'll box it. That's my interval of convergence. Check the answers, make sure you're doing it very thorough the way they do it, because they don't mess around. They want that one done right. And then finally, show the approximation part C is with 0.001 of the exact value of f of 1.2. I don't think I've even done C. Taylor series can be used to represent as an alternating series. The first three non-zero terms are approximate. So first three non-zero terms. That's why I said it's so important to have part A done right. So it's approximation of 1.2, f of 1.2 is 1, first three zero terms, minus 1/2. By the way, you won't see this year, because this is getting you into error bound, which is a nice question, but they're not doing it this year. Which is, if you blast all that out, 0.905, I think. Yeah. And then part D is actually very straightforward. If they're asking for, show that it's less than blah blah blah, you just go to the next term, alternating series thing, plug it in, so you're going to get the absolute value of 1 over 24, 1.2 minus 1 to the third equals, I don't know and I don't care, 1/5 to the third is 1 over 24 times 125, which is going to be less than 0.001. You might say, well, how do you know that? I say, because that's the answer. I know how to do the answer. The answer is take the next term. If I had a calculator handy, I would go 24 times 0.125 and say, oh, look, that is less than 0.001. And that's all they were looking for. Not on the 2020 exam, but, you know, not always going to be 2020. So there's 2 problems for you. Make your brain hurt a little bit, but doable. Good luck.